We shall now begin with the flash talks.
Thank you. So your brains are stuck in Golang routines, channels, concurrency, things like that. We're going to go a little bit abstract, one level above. I want you to start thinking about learning, notes, careers, things like that. And this talk is called Catchphrases to Shape Your Thinking. I guarantee you, at the end of this talk, your brain will expand a little bit. All right? So everything about me, I don't want to introduce you. Go to my website, everything is there, my photo, about me, all of that. Take a look so you can take me a little more seriously. All right, let's begin. So the format is straightforward. There will be a catchphrase, or as they are popularly known, aphorisms, and then a little quick explainer on what that means. Okay? Almost every catchphrase here is original, my own, that I keep using and telling my team or peers. But we're going to start with one that is not original, but I use it quite frequently. Show, don't tell. Anybody already familiar? Show, don't tell. Okay? So let me tell you, Golang is highly performant, right? Do you roughly agree? Yes, no? Okay? So let's look at the global leaderboard for the 1 billion row challenge, 1 BRC global leaderboard. And we'll see Golang is highly performant. What are the top 10 languages? Number 1, Java, 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 Java. So, all right, that's show, don't tell. I could tell you that Java is more performant than Go, but I could show you. Right? All right, next, collect the dots, then connect the dots. This is a way of thinking about learning and filling your brain with new things. Often we learn things, we do a lot of things, we read, consume, and then something happens that helps you cement those things in your head. So to learn and absorb, understand things better, what you want to do is you want to consume vigorously. You want to read a lot, see a lot. Even those reels that you scroll, you want to do that with taste. But then at some point in time, they're just going to click in place, right? Early in my career, I didn't understand how load balancers worked until I was on the on-call team of a production outage. And I had to suffer through an outage and the wrath of the team. And then everything I had understood about load balancers, I did on that day. Anyway, explain the experience. You're trying to teach somebody something. Don't try to teach them before they are about to experience. Let them experience, right? Sometimes, for example, if you want to give somebody a tip about how to book an Uber in Bangalore, you want to first let them book it and suffer the nightmare. And then whatever you explain is going to be much easier. Anyway, doodling is for toddling, notes are for thoughts. We have a nasty habit of doodling around when we're taking notes, and we mix our doodles and notes all the time. My advice, separate the two. Take lots of notes, but separate your doodling from your notes. Okay? Write what you understand, not what you recall. You can always use recorders and meeting notes to get back what you want to remember. But what you understand, you want to write it. 1.5 minutes left. It's never all or nothing, always a spectrum. Don't draw or give into random stereotypes. Engage spectrum thinking. I'll give you a quick example. Startups are better for early career than big tech. Anybody? Yes, no? Nope. Sorry. Well, then big tech is better for early career than startups. Anybody? Also no. It's not a categorically true assertion. It's a case-by-case thing. Don't make decisions based on categorical assertions. Similarly, only hire from IITs. Yes? No? Of course no. Never hire from IITs? Also no. Don't give in to categorical assertions. Last minute, foundation, specialization, category of one. This is my personal career building framework, very easily explained with this diagram. Foundation, first, build a rock solid foundation. Collect knowledge, build wisdom. Then build specialization. And then lastly, build 3-4 adjacent specializations that lead you to become the category of one, which means you are uniquely positioned at 4 or 5, a combination of 4 or 5 things that nobody else is better than you. Last 30 seconds, if it's only in your head, it must be in a document. No explanation needed, straightforward. When reviewing your work, such as this talk, you must reach a point where you have to edit things out, not put things back in. Same thing applies for PRs as well. Have more to say, put in lots of details, then take them out and create a narrative. Lastly, combat vagueness with analysis and simulation. All right, I'm just going to skip this and leave you with one last thought. Plan your career better than you plan your projects.
So if most of you are aware of what is OGNL, probably I can just go through the details. So what is OGNL? It's an object graph notation language introduced by Apache, and it's used in Apache struts in first release. It's open source expression language, which is Apache used to build this notation language, which is on top of it. Set or get properties of an attribute. So the basic purpose of this library is to get some properties out of the object or set it. Basically, it comes under MVC architecture, which is view and model. So it binds the view and model together. Okay, so this is an example. You can see there is a student object which has some IDs and some subjects. So these are the subjects that this student is assigned to. Then this is your application config YML, wherein this XML is looking for student subjects, which is at index 2. So how I can retrieve this information from the object? So this is what this lookup student function that is supposed to do. So if you see the first argument, that is student subject name, that is a OGNL expression that will be used by this lookup student function, and it will look for the second subject, which is index 2 that is mentioned in the last argument. So if you see the output, it should be science. So what is this lookup student? So as I said, this is a library which is responsible for retrieving this information. So the step one is the stub generation, where you can see it generates the lookup method, then it binds the OGNL expressions with actual attributes, and do some basic validations. So, and again, it has some support like basic data types and array and nested object search. So it's in initial phase. It can be, we can grow it together as a community. So on the right side, you can see the stub that is generated by this library. It's not a developer that written the code. It's totally generated by the library itself. So second stage is like to use that library into the actual code and to use that lookup function. So you can see that piece of code what I'm showing there. It was in the first slide. So you can see the output that was shown in the past. So this application and usage of this, it can be used for binding view and models together. Then retrieving the values from the structures using OGNL expressions, and data transfer from one layer to another layer. So this library is available on GitHub. You can use this QR code to just check it out. As I said, it's in the initial phase. So if you have any thoughts and if you see it can be done better, and we can collaborate and we can see if it's working. Yeah, thank you.
Hi, I am Prateek Singh Rathore, code maintainer at DiceDB. I was born and brought up in Jaipur. This talk is going to be about my journey with open source, and hopefully it will inspire some of you to take your own journey. How many of you have contributed in any open source projects? Please raise your hands. 10, 15%? No README file committers, please. Yeah, cool. How many of you are maintainers in open source projects? 1, 2, 3, okay, 4, nice, 5. How many of you can say that I'm really passionate about programming? Like, a lot of us are doing jobs, and some of us are probably, yeah. 20%? Okay, cool. So let me walk you through my journey. I realized that contributing to open source is hard. I've been coding for about 3 years. Everyone said you should do open source contribution, but they never did. So in my journey, I understood why it is hard. I think 2 reasons. The typical whys do not apply to open source projects. Most projects don't pay. There's no salary. There's no growth plan. There's no promotion to look forward to. There are no ESOPs. There is basically no upside that we are trained to, motivate ourselves. And a lot of people who do not have passion in programming, they find it difficult to start, because if you have passion, it's just easy to start. And second, there is no playbook. There are lots of tips and things, but there is no DSA playbook like open source, right? A lot of things are there, but there's no playbook customized for you. Now, this is me. I graduated from IIT Bombay 2010. I mostly worked in business roles for last 10 years. To give you context, in my last business role, I was head of North India beauty business for an urban company. And somehow I decided that I want to learn programming. I have been programming for 3 years, and I started from bottom as an intern, 40,000 rupees per month stipend. Then again, after 3 years, I realized that this basic CRUD work I don't want to do. I want to do something better, something different, because I've seen that journey in my last 10 years as business roles. So I decided to contribute to open source projects, and been contributing to DiceDB for last 3 months, and they recently made me a maintainer there. So like how dare someone can do that? Like, who does that, right? Like, what are the odds of a 40-year-old learning to learn to program, to contribute to open source projects, and that to a database project, right? And become a maintainer. I was telling this story to one of my college friend who graduated with me and now been programming in AI and ML for 15 years. And he asked me, like, are you kidding me? Like, the odds of being successful are generally much higher than what we think. I think you just need a bit of courage and faith to keep moving forward no matter what happens. And the most interesting thing about open source was, because those incentives are not there, you are forced to find different set of incentives. And that is where there's an opportunity to discuss a different, discover a different why or your passion, right? The undiscovered, elusive passion, which I think all of us have. We've heard of it. So what did I discover? This is my playbook, right? Like, you have to start from something which is your undeniable truth, that I love Go. Okay, so let me find projects in Go. You have to stick with one project. Start reading all the conversations in the GitHub. Read test to understand code bases. Make your first merge commit. Raise your hands to pick up work. Build relationship with maintainers. Help other folks in the community. Put yourself out there. Very important. This is what I'm doing here. Above all, it's play, not work. You cannot approach it like work. It will create a lot of stress. Do not set any goals. Do not have any expectation. I think this worked for me. And this was my why. The joy of being thrown into anything. Like, I don't understand the code bases. I don't know what concurrency is. I do not understand profiling. And figuring out my own way from there, right? Like, so I realized that I love debugging complex things, especially different microservices. I love understanding complex code bases and simplifying it and probably explaining it to someone else. I love figuring out things on my own. I don't want a senior engineer to come and help me. I want to read books, whatever, I will figure it out. So go and contribute to open source projects, build your own playbook, and probably you might just find your passion as well. Thank you.
Hi guys, how's the Josh? This is not Joshful. I guess everybody's sleepy. No worries. So I am Ajinkya Karanjikar from Josh, and you must have seen me on the Josh Software's booth wearing different t-shirts. But if you're not, then it means either you're paying really good attention to the talks or you're feeling sleepy. Okay, so here is a very important question for you guys that I want to ask. क्या आपके टूथपेस्ट में नमक है? Okay, you may be wondering what kind of a dumb question this guy is asking on a stage. This may not be relevant right now, but this is. So trust me guys, this is a very, very damn important question for many startups and new coming softwares today. Everybody wants to have this kind of namak in their AI. So yeah, let's go ahead. So earlier days, when AI was not ChatGPT, AI was not OpenAI, AI was portrayed like this. Dumb robots doing everyday laborious work in not so efficient way. A little bit ahead on the time, we had humanoid robots, robo hands solving Rubik's Cube, traffic monitors, how many cars are there, how long should the red light take, and everything. That was happening. But when this was happening in the scientific community, we were having this. Everyday people like you and me were looking at movies, and this was how the AI was portrayed. You must have seen the Terminator movie, right? Yes? Any DC fans here? So now look at this one. It's a full metal robo capable of destruction, humanoid destructions and everything. Now this guy has teeth. I mean, What the hell you need teeth for when you are an AI robot, right? You're not gonna definitely eat sandwiches or something. But yeah, that was how the portrayals were. While today, the AI community working on something like this. You're building a program to identify a dog, you run it, and that's what you get. A cat is identified like a dog. But when we are going further, the AI is like a child with all the powers. The brain is not yet developed. And that's what we are doing, right? We are retraining the models and doing a lot of things. The AI progressing, getting better and better every day, maybe even in faster pace than what we did. So let's check out today's AI. I asked this simple question to ChatGPT an hour ago. I have a 10-liter bottle and a 5-liter bottle, and I want to measure 5 liters. What would be the answer? Just pour it in the 5-liter bottle, right? You have 5 liters of water, right? Very simple question. This is the answer I got. It's a 4-step process. Fill the 10-liter bottle completely. Pour the water from 10-liter bottle to 5-liter bottle till it's full. Then empty the 5-liter bottle completely. Now the 5-liter bottle is empty. Pour the remaining 5-liter water from 10-liter bottle to 5-liter bottle, and there you go. There you have your 5 liter of water. Now imagine you create a water pouring machine using ChatGPT. Right? That's what's going to happen. I asked the same question to Llama. Llama was less lame. It was a 2-step process. Fill the 10-liter bottle. I can't get what's the obsession with the 10-liter bottles. But yeah, fill the 10-liter bottle, put it in the 5-liter bottle, and there you go. So when I was doing this, I got a question. If this is the question asked to us, क्या आपके सॉफ्टवेयर में AI है? And if the AI looked like that, would you be feeling so proud in saying, yes, हाँ मेरे सॉफ्टवेयर में AI है? Right? So I think today's AI is not about putting a star in your software's resume. It's about telling you what to do with the AI, what not to do with the AI, where to use the AI, where not to use the AI, and what are the problems that you should be solving with the AI rather than integrating the AI first in your software and then finding problem to solve with it. So with that said, thanks for being here. That's it.
They analyze the source code. These are language specific. And then they can detect the patterns and find the security vulnerabilities. On the top 3, you can see these are open source, language specific, Golang, GoSack, Ruby, Brakeman. And then there are like a vendor tooling, SonarQube, and then the top in the industry, security standards is the GitHub Advanced Security. It is used for like almost all the languages. Then DAST scanning. These are dynamic scans. So you have a running application, you hit it with like a lot of requests, and based on the response, you determine like what kind of issues are there. So it is like language independent. The vendor tooling are Qualys, VAS, and Burp Suite. These are some of examples. Then there should be secret scanning. So there shouldn't be any secret added into the code base. You can use pre-commit hooks. So in the local development environment, you can you can run these scripts. These are like git leaks, Truffalog, git secrets. These are open source tools. You should be adding in your pre-commit hooks. So these pre-commit or pre-push hooks, it runs before, before the commits or before you are pushing to your remote, your version control system. So it runs and it detects and blocks. So you should be running that. It should not be going to the commit history, right? So that's another thing. And then software composition analysis. This is basically, the tool is looking at the dependencies, external dependency, open source dependencies. So it looks for in case of Golang, it looks for Go mod file, or Ruby, it looks for gem file, and then it checks like what is the current version, what vulnerabilities it has, and then it will tell you to bump the version. So the tools are like Sneak, Dependabot. Dependabot is from GitHub. It's a free tool from GitHub. Then we do license scanning. So copyright, you almost you have heard about that. Copyleft licenses. Copyleft basically, I have given an example. So AGPL licenses. So if it says like if you have that, if you are using that copyleft license code into your code, then that would require your code to be shared, your proprietary code to be shared as an open source. So you shouldn't, you don't want to do that, right? So you shouldn't be using these copyleft licenses. So you should be reviewing it from your legal team, what licenses are there. So yeah, that's mostly from me. Thanks. If you have questions, you can connect me.
Yes, one more concurrency talk. We are all ready for it. So here is some interesting use case that we worked on. I want to quickly talk about it. We did a migration from MongoDB in terms of data to a relational database, Postgres, right? So it was kind of a one-time bulk transfer of data and then also moving the data in streaming fashion continuously. We are kind of discussing some use cases about performance, scale, etc. around that tomorrow as well as part of panel. But here I thought I'll quickly give you an idea of the kind of work we did. So because this is a flash talk, I won't have time to go into why did we start reading Mongo oplog of all of a sudden, but bear with me. So here is a sample oplog. What we do is we convert this into a relational structure, something like this. So it's a student table. Your database goes into student, your student database, your collection in Mongo becomes a table in Postgres and stuff like that. And then the columns get mapped and whatnot, right? So finally, what you end up with on the input, on the left side is a Mongo database. On the right, you have a Postgres SQL statements that you execute. So we build a sample sequential pipeline. This is what it looks like. You read oplogs, and then these are the Go routines. These are the oplogs, which are channels. And here is how the pipeline works at a very high level. Well, we did run it, but it ran very slow. So we started improving the performance by adding like worker pools, right? So we're like, okay, where do we add worker pools? So you can add it on the two areas, like this one is doing too much work, so it needs help. Similarly, the execute SQL as well needs more help. So you add Go routines there. And this is what we end up with, like Go routines with orchestrating as a worker pool, etc. By the way, don't worry, no gophers were harmed in this exercise. Now, the problem, the good part is that there is a 4x reduction in terms of runtime. So that's pretty cool, super awesome performance improvement. We went from 8 hours to 2 hours. But the problem is we ran into some domain issues, like we started running updates before inserts. Like there is nothing in the database, you're trying to run an update and you have to actually run insert first. So, well, the orchestration and the coordination was a problem. So what we ended up doing is a concurrent data pipeline. Again, I'll talk about, like, this is what we ended up doing. You start again reading oplogs, you have a oplog channel, you push all of the oplogs there. Then you fan out for each database, you create n types of channels. So these are n channels for each database. And for each of that channel, you have a Go routine, which then for each of the collections in Mongo, you create one more fan out, and you end up with per database, per collection Go routine. So it's like n number of Go routines multiplied by m number of Go routines. So that's like too many Go routines. But well, and then you kind of fan them all into a single channel per database. Because then you can have a SQL connection and you can start inserting data into the database. And then that's how you kind of do the transformation. So this, once we run that, this got us almost like a 6x performance improvement, all good, from like 8 hours to 1.3 hours. That's pretty good. And that's it. That's all I want to cover. There will be a good discussion on this tomorrow. Connect with me on LinkedIn, Twitter, etc. This problem statement is open for you to try as well. It's part of that SRE and Go bootcamp that we have. So I would recommend you guys check it out and try this out yourself. Something interesting for you to see and learn the power of Go routines in action and try out for yourself. All right. Thank you.
Hey folks. So as it's evident, I'm from Market Feed. I'm a senior software engineer for backend systems. So today I'll just give you a brief of how we kind of daily deploy about 300 crores of AUM into Indian options market. By the way, we're going 10% to 15% month on month. All right. A little bit of context how Market Feed works. Pretty simple onboarding. You get your trading strategies, you link your trading account, put some funds, and the automation system takes care of it end to end. You essentially put your money and forget about it. Cool. So the entire trade automation team, which is 3 engineers, is present at GopherCon. What this team does is it enables operations to deploy any and whatever the supply is, and the supply essentially is the EM capacity of the strategies in Indian options market on a day-to-day basis. This team made the architecture scalable to accommodate about 1,000 crores of daily deployable EM, and the current architecture runway is about 2 years, which means until we reach 1,000 crores, we don't have to rewrite the architecture. Pretty simple. We have a strategy service, then we have a trade automation platform which the strategy service talks to, and then the trade automation platform tells broker what to do. I've kind of dumbed it down a lot, so yeah. But this works maybe for like a couple hundred of users, right? And now we're growing. How do we kind of handle that? And how to scale? So as the number of users grow, because we are a B2C company, the users order compete with each other, and then sequential processing is bad. And how do we know if the service can handle high enough AUM with a guaranteed stability, right? And which service model or architectural design works best for our specific use case, and if the service is highly available or not. So answer, pretty evident. The service is built on top of Go. We do parallel processing. Whatever can be done parallelly should be done parallelly. You distribute processing across multiple instances, and you keep state outside the service, but if it affects performance, you sacrifice statelessness, which a lot of people have talked about here for the greater good. And you, of course, have ways to recover state if service degrades and recovers. And persistent connections for order status discovery are relatively more performant in these scenarios. And you essentially perf everything end to end. So there was this talk about contextual logging. We have perfed a lot of logging libraries in Golang because, of course, critical systems. So service availability. For our use case, we thought that K8s is maybe a little too complex. So we wrote a service registry, service discovery ourselves. And the service discovery that we wrote takes care of instance recovery, instance identification, task segregation, all the good stuff that you get. Why, you can ask me after this talk. So this essentially limits the number of users per instance, and in turn takes care of controlling the number of Go routines. And this, we also kind of, from the day one, promoted that we want service visibility. We pprof, do distributed tracing, have Grafana, New Relic dashboards, whatever your choice of preference is. It's a very high level overview, and of course, we are hiring, so this was an ad as mentioned in the beginning. So yeah, thank you.
Hi everyone, myself Surya Prakash Gond. I'm working in Silver Post, that is based on Gurgaon. All guys, आप लोग YouTube पे प्रचार देखते होगे, एड्स देखते होगे, कभी स्किप कर देते होगे, तो उसके पीछे हमारी टेक कंपनी काम करती है. तो now I'm working on Chocolate, that is a ad exchange of the Silver Post. तो Chocolate product, it serves billions of the ad requests per day. So that is totally written in Go, and it's based on the pipeline structure. So we are when we are writing any codes, we think about time, CPU, memory, everything. So for that we are using profiling in each case. So what is profiling? Profiling is the technique to optimizing the performance of the Go application. Go provides the built-in package for profiling the code, that is net HTTP prof. It is helpful to optimizing CPU memory IO usage. When to profile? Before production or during debugging performance issue. So, so the profiling tool in Golang, that is a pprop. So how can we set the profile in our Go code? So there is a package net HTTP pprop. So here you see we are using the server for the profiling HTTP servers, and so there are lots of commands which have in pprop: top, list, web, and web list. When we profile our code, it's like it gives the time which piece of code taking time when we do profiling of the CPU, it will give the which code of piece take more memory. So that's how we can utilize the profiling in our code. Thank you.
So, good evening, everyone. I'm Harsh. I work at Quick Insure. We are based out of Pune, and we are technologically India's #1 insurance broker. So, we have got almost 40,000 plus certified agents with us, and our main goal is to issue the policies throughout all the insurers which are available in India. So, we are technically integrated with all of them, all of the insurers which are there in India. And one fine day we got a task, basically every financial organization has got a challenge of doing reconciliations. So basically in our case what we are doing is we issue the policy, and after each policy we have to also process the commission to our agents. So basically whatever the amount of the policy is, we issue the commission based out on that particular amount. But the main challenge happens after that. Basically sometimes policies get cancelled, sometimes the user have entered wrong information, because of that the commission gets changed. So every time we issue the commission instantly, but we get the details after 1 month or let's say 45 days from the insurers. So our main challenge is to reconcile all those things and decide what is the exact premium or what was the exact commission which was supposed to go. So we decided to create a small application. Before that, before the application, the work was done by a person was there who used to compile all those files in an Excel sheet, and then they used to present all those. They used to combine all those files and then they calculate using all those formulas. But we decided to go with ClickHouse and Go. Go, probably everyone knows about Go with all the features, but we discovered that ClickHouse is one of the better solution instead of Postgres, because it also gives us multiple aggregation functions for inbuilt to get the summations done and everything possible. And this has got so many other benefits you can definitely check out. For us, it was the aggregation function majorly, which we took out as a primary thing. For that, I just have few a simple demo where this is a simple creation formula. This is creation syntax for a table, where we are creating a table, but while creating a table we are mentioning that we will be using summing merge tree. As I mentioned earlier that for a single policy we get multiple records, but policy number mostly remains unique, but there are multiple entries for incoming and outgoing transactions, and at the end we have to figure out what is the exact amount after multiplication, after summations and subtractions. So we have put a summing merge tree engine here, and this is a simple demonstration of the same. We created a table, then we inserted rows. If you see here, the policy number remains same for all the 3 records, but the commission amount changes, 10,000, then 8,000, and then minus 3,000. So at the end, what we are expecting is the actual commission which supposed to go is 15,000. And if we consider to do it in Go and keep only 1 record in the system, then we will have to do a lot of computations in Golang or say any other language if we pick up. But with ClickHouse, we have got this optimize option where we just have to run a single query in our whole program, and at the end we get this kind of result where we get to know what is the exact commission which was supposed to go, and we have the record. And earlier, which like the task which used to take days and manual intervention by a person, it is now being done by a small program and with just minutes. Yeah, that's all. Thank you.
All right. Hey, everyone. I am Jaideep Shinde, and I work as a senior software engineer at PubMatic. And yes, I have brought in concurrency again. But no, I'm not just going to talk about concurrency. I'm also going to talk about parallelism. So let's go. Okay, so the first question would be, isn't concurrency the same as parallelism? Right? And that's what the Spidey is confused about as well. The answer is no. So concurrency is something different, right? So I think there has been enough talk about concurrency. Let's talk about parallelism. So parallelism is basically breaking up a task into subtasks and execute them simultaneously. So you can think of it something like, we get a feature to work on, and that feature, let's say it can be distributed in two different tasks, two different independent tasks. You give one task to one developer, other task to the other, and they both do it at the same time. So this is parallel execution of the tasks. So this is like one of the good examples for parallel programming. And it sounds like a very, very easy thing to do, and actually a very great thing to do. But the problem is, in the real world, which is pretty sad, you don't get to distribute things for parallel programming, right? Because things aren't really independent always. And that's where we get concurrency. And now what the hell is concurrency? We've been hearing about it the whole day. Let me kind of, give a very basic definition for it now. So by definition, concurrency is the ability to break down a computer program or algorithm into individual parts, which can be executed independently. And I know it didn't make any sense for now, but let's look at it with an example, and maybe it will make more sense. So let's go. Okay. Firstly, I think two quotes, which will distinguish everything, and it will make things so much clear. Concurrency is about dealing with a lot of things at once, right? Dealing with a lot of things at once is concurrency. And then parallelism is doing a lot of things at once. Okay, let's take an example, a very relevant example, which I think we will all could relate to. So that is, what is Spider-Man's morning routine, right? So let's go. Let's see. So Spidey wakes up, right? Like everyone else. So he wakes up, he brushes his teeth, which is mask off, of course. Then he showers, which everyone has here today morning, I hope. He prepares breakfast, good healthy breakfast. He eats it, and then he goes to work, right? Now, we just discussed a nice flow of, or a task, right? Morning routine that he has to do every day. Now, let's see how we could implement this. So a sequential approach is what we just discussed. That is what he does every day, one by one. Now, if Spider-Man would have attended my course, and he would have attended this flash talk, he would have been smarter about it, and he could have gone for a concurrent approach. What would be a concurrent approach? So when he wakes up, he goes to brush, but before even brushing, he knows that he has to prepare breakfast, which doesn't happen in a click. So what he could do is he could actually start preparing for the breakfast right away before even brushing. So he could maybe get some breads, get them toasting, and then go and brush. Do something else, go to shower, go take a shower, come back, his breakfast would be ready, and then he could do it. But I think the point to be noted here is he's the single person who is doing everything, right? He's just planning it better so that he could do most of the things in small amount of time. That is the concurrent approach of doing things, right? And then the parallel approach, which I think is my favorite, where instead of doing everything, you wake up, you open Zomato, order something, order is getting delivered to you, you get all the other things done, and by the time order comes, you just eat, right? So, so the thing to be noted here is in parallel, task of preparing breakfast has been taken care by someone else, right? He is not the one doing it. So that's would be the basic difference, and that's will be the end of it. Thank you very much.
Hello everybody, I'm Prashant from Funnel Story. In this talk, we'll see how we can implement a distributed lock using Postgres. And this is what a consumer of the distributed lock that you're going to implement. This is what the consumer end would look like. If you are familiar with sync.mutex, this is exactly that, but across process boundaries and network boundaries. Let's go straight into the demo. So here I'm simulating running the same process or service on 2 different machines. So let's say this is one machine and I have another machine here. And process 1 has acquired the lock, and the process 2, which is on a different machine, has attempted to get the same lock, but it has failed to do so. So this is the non-blocking version of a distributed lock. Let's make this the locking version of the distributed lock. So with the locking version, what we expect is when you have multiple instances trying to acquire the same lock, when one process has acquired the lock, other process will block, waiting on the same lock. So here you can see that process 1 has acquired the lock and released, and then process 2 has acquired the same lock. So this is exactly like your sync.mutex. While your sync.mutex stores the mutex state in the runtime memory, in this case, we store the mutex state in a Postgres database. All this in under 100 lines of code. So we'll see what primitives does Postgres provide for you to implement a distributed lock. So here's a bunch of things. I'm going to go through each of them one by one. First thing is we have role level locks, and these can be accessed using select for update statement. What this does is if you have a transaction that uses select for update, all other transactions that are trying to access the same row will be blocked unless the transaction that has gotten the lock either commits it or it has to roll back, right? What if you do not want other transactions to block? What if you want them to detect that somebody else has acquired the lock and I don't want to wait, I want to bail? So in that case, Postgres provides a no wait option where if it is trying to get the lock and it is not able to, it is going to error out, right? And what's the primary use case to have distributed locks? So one of the use cases is to implement a queue like SQS. Let's imagine you have thousands of jobs, and each of those jobs need to be dequeued from somewhere and given to a worker pool, similar to a bunch of Go routines reading from a channel, but think across process boundaries and across network boundaries. So in this case, let's say 10 of those 100 jobs have already been given out to 10 processes, and one of them finishes processing that job, and you need to fetch the 11th one, right? So in that case, Postgres provides the skip locked clause, which will allow a client to fetch all the rows that has not been locked earlier, right? So that is also possible using the skip locked option. So now you might think, what if a process acquires a lock and it dies, right? So in that case, since the lock is tied to the duration of a transaction, if the process dies, the transaction gets rolled back and that lock gets released. You might also think you may not want to indefinitely wait on a lock, right? In that case, Postgres provides lock timeout, where you can say that I'll try to get the lock, but only for 5 seconds, right? So using all these primitives, you'll be able to implement a robust distributed lock using just Postgres. So I'll just briefly go through the code here. As you can see, it's just 3 statements and under 100 lines of code, more or less. You can check out the code here. Thank you.
Hi everyone. So today I'll be talking about Go routine local storage. So I am Puneet. I work at Instabase and I have 4+ years of experience in Golang, Python and Kubernetes. I'm very passionate about solving complex problems with simple solutions. I try to spend more time on removing code rather than writing it. So First of all, what is GLS or Go routine local storage? It's a mechanism to associate Go routine specific state, similar to thread local storage in other languages. And you basically get to store information like a key value pair for every Go routine separately, and then you can access it from anywhere in your code. So now the interesting part, how do we do it? Golang does not support it by default. So there is this library on GitHub which allows you to have this ability to have a local storage. So you basically use this library, you call the Go function differently, and what it does is it will generate a unique ID. So whenever you call this function, it will generate a unique ID for your Go routine, and then based on that ID, it will make a bunch of function calls. So on your right, you can see there are these functions. The first one is the last letter of that function is S, which is the starting of your ID. And then you have all the hexadecimal characters from 0 to F. This will basically call all these functions based on the ID. And then whenever you want to get access to your data in that Go routine, what you can do is get the stack trace from your runtime library, and then using the stack trace, you can get the ID of this particular Go routine. And with this ID, you can have like a map where you can store all the information about that Go routine. So moving on, when should you use it? Never. So basically the correct way to do things, and the Go recommended way, is to use context for passing any kind of information. And this is definitely not suggested. Even if you see the GitHub library, you'll see all the comments there. But having said that, when we work in a real world code base, it's hundreds and thousands lines of code with 100 people working on that code base. So you will see a lot of context.todos and context.background where context is not passed properly. So you miss out on all the information that you passed. So in those cases, you can have this hacky solution where you can use GLS to get that information. And for me personally, I used it to inject trace IDs into the logs. So basically it's like a request ID or a correlation ID. And that was used to like filter logs and do other things. So yeah, in conclusion, GLS provides a way to manage Go routine specific state, but it's not idiomatic to Go. You should prefer context.context, and if you are using GLS, you should be careful because it does a lot of things in the background and it can have a huge overhead. I've also added some of the comments from the GitHub page, so yeah. Thank you, this is...
So don't worry, I'm not going to bore you. So hi, I'm Nikhil and I'm from Josh and I work as a technical manager. Today I'm going to talk about something special which is very close to my heart, that is my traveling habits. So usually I travel on weekends, and quarterly or semi-annually I travel for long period. Sometimes it's adventurous trip, or sometimes it's a relaxing beachside retreat. Why I travel? Because I love to explore local cultures, then their traditions, and I'm a foodie, so I love to try different cuisines. So these are some pics when I was traveling to Singapore, Malaysia. There is a very unique pic where some Bali localites are performing on our Indian epic Ramayana. So that was very interesting. That is called Kekak dance. This is story for everyone, no matter if it is wife or girlfriend. Yeah. So how it correlates with your work culture? So definitely it helps to release your stress. You meet different people in different places, so it definitely change your perspective how people are, and it adds on in your creativity. It helps you build a stronger connection because there are different peoples in different locations. Their cultures are different diversities. So no matter how busy, how techy you are, you should definitely start traveling. These are some pics again from Bali and Maldives. Yeah, how I plan my trips. So first of all, I set my budget and then I start planning. I decide my destination, then I research a lot. I research on YouTube, then some blogs, then on authentic government sites if I'm traveling abroad. Then I need to take care of flights, hotels, everything. Then if I'm traveling abroad, then I definitely need to carry a local currency. Then I pack my bags very light because I usually don't shop, but if there is something which it will not, I can't get at my local place, then I definitely buy that. And I'm definitely flexible in terms of setting itineraries, because if you in hurry for completing every location, then it may ruin your relaxation. And the last, don't over rely on anything, because if you overuse Google Maps, then it will take you like anywhere. Yeah, this is, you can connect with me on LinkedIn and Instagram. And I just wanted to tell one small story on my experience. So I was traveling to Thailand on my honeymoon with my wife. What silly. Definitely should be with wife. And with banker, when I inquired, then banker told me that you can withdraw 15,000 cash from ATMs. So I was carrying very less cash. And when I arrived at Bangkok airport, I was able to withdraw around 7,000 baht, which was around 15,000. And after that, I could not withdraw in cash, and I was like, what can I do now? Because I was with my wife on my honeymoon. So we were like searching local Indian restaurants in Bangkok, and we were requesting, please give us some cash and we will swipe our credit card on your POS. Somehow one restaurant owner helped us, and after that, on second day when I tried out, it was per day limit. I discovered it later. So yeah, so learning was carry sufficient cash with you. Thank you.
So hello Gophers. So I'm Asif Nishat from NPCI. I'm currently working as a blockchain developer. So today I will be explaining about Go Embed package. So basically I will be explaining the process of streamlining the process of Go application using Go Embed package. So I'll be explaining how we can use it and streamline the process of deployment of Go application. So moving on to the next slide. So I'll be talking about how it works. So we'll be using this Go directive, Go Embed. So from there we can directly import the files into the binary itself. So coming to the first point, so at the compile time only, those files will be embedded into the binary itself, and from there we can easily use it. So basically this embed package provides with us 3 data types. So first is byte array, another was a string, and the other one is FS type, which is the special type which we can use to embed multiple files. And it's just a implementation, it implements the IOFS package only. So any other package which will be using this file systems, they can basically use this one as well. So we can embed multiple files using the Go directive, and we just have to specify the path that it has to do. So it is the read-only by value. So it can be accessed by multiple Go written simultaneously, and it's totally safe to use. And it basically gives us a few methods like read directory and read file, and from there we can use it. So moving on to the use cases. So basically we can use it to embed the configuration files, which can basically make our deployment process much easier. So currently we have to make config maps and all those things, and from there we have to basically by using this we can basically remove the external dependencies, right? So we can just embed this particular let's say template or whatever configuration file into the binary itself, and from there we can if you are using let's say Viper package, so we can obviously use that to, let's say, override those configuration values. So it's much easier if we do it this way. And we can include static web website assets like HTML, CSS into it, which can be used. And the third one is most important, like we can give Redis Lua file scripts, all those things, and data migration files. We can directly embed into the binary, which can be directly used. So we don't have to provide it externally and do all those things. So it will be there in the binary itself. We can share it with anyone. And once they execute it, so we will have the binaries and all the tables and everything. The initial DB migration files will be there, so there won't be any issue. And the last one is like we can bundle multiple binaries into a single binary, and which can be used. So there are more use cases, but these are just few examples which which I have myself found very helpful in my what I do in that. So I will be doing a quick demonstration after this. Let's say I have this repo, and in this Go workspace, I have two different repos like repo 1 and repo 2. So using this syntax only, I can directly embed this file, this particular directory which has two binaries, repo 1 and repo 2. And basically I'm using that embed package, I'm basically running it. So I just have to build this binary with this after adding this syntax. So it will basically embed whatever these values are there in this particular folder, and it will inside in this Gopher binary. If I run it, so it will be there. Okay. Okay. So in this file, I'm just basically executing what's there in this repo. So in this repo 1, I'm just printing this whatever hello p1 or whatever. So if I just have to source this binary file, and I can just execute that particular binary which is present in this bin directory. So I just source it. Okay, so first I have to build it, then and I can directly run it, and it will show us the contents of that particular binary. So currently we are using this repo 1, and we can use this particular read directory, and it will basically display all the files that are present in this particular folder. So in this binary, we have this repo 1 and repo 2. We can see the output here. I also written this small benchmark file. So it will be basically comparing this embed package with the basic one, normal one that we use, that is io.readall. So after running this, we can see there's like basically no comparison, right? It's like much more faster than the normal one if you are using for that. So that is it. Thank you.
Hi guys. So my name is Mridula, and I am from NPCI, and I work as a associate blockchain developer. So yeah. So today I'm going to talk about scheduler in Go. So how many of you are aware of the scheduler? So yeah. Okay. So what is a scheduler? So basically scheduler is an algorithm which manages the task and their execution. So it ensures that the CPU which is there doesn't take up much usage, like limited usage, because in scheduler we will be using the Go routines, OS threads, and the processors. These are the key components. So processors generally do like assign the Go routines, which Go routine should run on which thread, and the M threads are generally the OS threads, which everyone knows, and the Go routines, like it represents the individual task like which are then be assigned. Now why we have to use a scheduler? As we know that Go routines are lightweight. So there are few benefits of using a scheduler. The main thing is it has a work stealing. What is mean by a work stealing? For example, if we say that we have a processor, it's been assigned through like from some tasks, and like all the tasks have been executed, and it became an empty thing. So then it will take a overloaded processor and then steals the task from that processor, and it will do that task like in the sequence manner. And then like we have in Go in 1.14 version, the preemption scheduler has been like introduced. What it does like if a Go routine runs longer time, then it will stops that Go routine, and then it will consider the other tasks which need to be run. And scalability is one more thing, the benefit in Go scheduler, that is like it does millions of Go routines on limited resources. That one more thing. And we can apply these in real world applications like in payments, in distributed systems and everything. And then how does Go Scheduler work? Like the Go Scheduler follows one routine like GMP model. G means nothing but Go routines, like as we know that these are lightweight, and M is nothing but M threads, like it is the OS level threads, and P is for processor. Processor means like it is a context which gives which Go routine should be running on which thread, like that. So execution flow for this scheduler is one, the Go routines are being created and they will be queued. Then after that, the processor decides which Go routine should be on which thread so that the execution can be done smoothly. Then after that, if the processor executes the everything and every task and it get emptied, then it will take the it will steal the task from other processor and then continue its work. Just I have written a small code regarding this scheduler. It's a sample and a simple one. So this is the code. So here, okay. Yeah, so like general is a simple one. We will be defining a function like task, and then a scheduler struct which manages tasks and executed them based on the schedule, like whatever the time we have been given. And then we'll be having a function called new scheduler that like initializes and returns a scheduler which we will be defining. And after that, we have a function called schedule. Like in this, the task will be executed, like specific task, whatever the task we have been given, that will be executed. This is the main thing. This is the main function like start, like where it will check for the task, like whatever the multiple tasks are there, that will be checked. And then it will execute on the like first come first serve basis, like that, whatever that we have given. So these all things will be included in main function, like the scheduler implementation and the task, whatever we are giving, and the sleep, like the time, everything. So I'll just run this one. So it's like it takes time. So it's triggered the event of email, it triggered the event of report, and it's executing first the email task, and it is giving the whatever the response message is there, and then it is executing the report task, and it is given the response for report task itself. Yeah. Thank you.
Hello everyone. I am Aman Thakur. I work as a blockchain developer at NPCI. I'm using Golang for last 2.5 years. Today I'm thrilled to discuss on a critical yet often overlooked concurrency pattern in Golang, which is confinement. So, being a developer working with concurrent systems, we strive to achieve for easier and safer methods to access shared resources. Confinement is the tool which will help us in a straightforward and very easy method to achieve it. So, what is confinement? Confinement is a concurrency pattern where a data is being shared and accessed by only a single Go routine. Like no other Go routines can access it throughout its process. So it provides a sense of encapsulation and even a data ownership, enhancing more scalable code and less Go routine leaks in production. So now moving towards why. Why do we need confinement? It will ensure us to not to get race conditions and not to use external packages, synchronous packages like locks and all. So it makes our code more scalable and even more simpler. Now, without wasting much time in explanation, I will show you a live demonstration how confinement can fit in your use case. So this is my main method. Consider it as a real life use case where our input slice, which contains 5 order IDs. So as a firm, I need these 5 order IDs to be processed simultaneously. So what I did, I iterated over this order ID slice and passed each Go routine to generate a shipment ID
for the corresponding order IDs. So my result slice, which is a shared resource in my case, will contain all the shipment IDs of all these 5 order IDs. So now look, we can look the process order method. What it does, it generally calls a create shipment method. Create shipment method will do some of its time. Here I have done like it will take some milliseconds to process the order, and finally it will return us with a shipment ID. So when we get that particular shipment ID, we will just append it to the result slice. So this result slice, we are all the 5 Go routines will be accessing this result slice. So when we run this program, we can see like all the 5 order IDs have got a particular shipment ID, and it took around 2 milliseconds. Now if I run this program for multiple times, I have written a script to run this main.go multiple times. You can see some abruption, like the program is not executing as it should. Sometimes the shipment IDs, there are only one shipment ID, but it should not work like that. All the 5 orders should have a particular shipment ID. To avoid this condition, what we do generally, being a developer, we apply locks. We use mutex, we apply locks over the critical section of our program. So if I use this method, and run my forever script, now you can see there's no inconsistency in the result slice. All the 5 order IDs are getting a shipment ID, but there's a glitch. It is taking around 10 milliseconds or sometimes 11 milliseconds. So it's a bottleneck. Mutex comes with a bottleneck. So to overcome this, there's a confinement method I have written where we are not passing the pointer to the resultant slice. Instead, we will pass pointer to the particular index of that result slice. So just a minor change I will do. I will take that. And here my result slice, I have make that result slice with the length of that order IDs, so that each Go routine is now confined to a particular index. If I don't do this, then it will give me a panic. Now when I run this, so now you can see the code is running perfectly and it is taking 2 milliseconds only, not taking that 10 milliseconds. So this is the power of confinement. Thank you.
So what is PGO? PGO stands for Profile Guided Optimization. As the name suggests, it guides the compiler to optimize your binary based on profiles. And profiles can be of 2 types. The first one is the memory profile. The second one is the CPU profile. So how the profiles are generated, I think some of the other guys also explained that there is a runtime /pprof package and the net/http pprof if you want to host it to the server. So I'll not go deep into how the profiles are generated. We're gonna see when we'll move to the code. So the next question, that is how it helps the compiler to optimize the binaries, right? So what compiler does is it actually, like without passing any profiles to it, it do optimizes. But it cannot, so the optimization can be of few types, like inlining a function, detection of the dead code, all other things like that. But it cannot inline everything, right? So if it inlines everything, the binary will be bloated and it will increase the pressure on the iCache. For those who don't know iCache is the instruction set keep the close to the machine so that it can execute it betterly, like with the low latency and all. So it increased the pressure on it. So that's why compiler cannot inline everything. So it needs some data, some kind of input to know what can be inlined or what not. So in order to understand that, we're gonna move into the code and I'm gonna show you guys how it happens. Is it visible? Yeah, I think it's visible. So here I have written so what I'm doing is I'm importing the runtime pprof here. And so this default.pgo you see here, it's the default name that the compiler uses. So when you run a Go file, it first builds it and then runs it. I think that everybody knows here. So what compiler looks for is look for this default.pgo file if it is there, or else you can like feed it to the compiler using
the flags and all. So what I'm doing here is I'm just creating a profile and I'm doing some recursion kind of a thing. So I'm calling the func1 like 500,000 of time, and then the func1 is calling the func2. So we're gonna run it and we're gonna see what happens. For the time constraint, I have just have the things here like the commands so that I can use it well. So you see here what I have done is I have just before the PGO kind of a thing I have kept it here. So I'm gonna just do it a little quicker. So you see it's just running it, and it creates the default PGO. So right now what is happening behind the scene, the moment it creates, I'll tell you. So what happens when you compile a binary, it actually creates an ABS, which is abstract syntax tree for the functions. And after the abstract syntax tree is created, it moves to the IR, which is like the immediate representation, intermediate representation of a code. So now what happens is when this IR is created, how the compiler know, like, okay, like now I'm calling this func1 like 500,000 of time, how compiler knows it. So what it do is it injects the hooks to actually take the data from the runtime, that okay, this like a global counter to it, okay, this function has been called this number of times, and it is taking this much time to execute. So these functions which take a lot of time, lot of IO operation, taking a lot of time in execution, are generally described as hot functions. And these hot functions basically, okay, I'm out of time. So these hot functions it helps you to know okay, what is happening inside and what are the bottlenecks we have. So just okay. So now what happens is, yes. So now what happens is I have created after PGO and I have given the default file to it, like the default PGO to it. So now what you see is it is inlining the function 1 and the function 2. So now the compiler knows actually, okay, it has been running 500,000 times and I should inline the functions. And for those who does not inline basically means it copies the body of the function and pastes it where it's being called. So yeah, that's how compiler do the PGO. And if you guys have any question, because of the time constraint, I was not able to explain it fully, we can connect later. Thank you so much, guys.
So what is terminal UI? So basically it is an interface which provides user-friendly experience within a command interface, command line environments. Okay. So do you guys recognize this image? Yeah, this is the Vim terminal. Like this is the best example of the terminal UI. We use this to edit any text documents. So where we use the keyboards to input this terminal. So it accepts the keyboard inputs. So this is the best example of the terminal UI. So why we should use the terminal UIs? So basically, terminal UIs are the lightweight and fast, and it will reduce the redundant works. Imagine you have a backend application. Most of the time, we have a backend application which have most of the we have more components, and how we interact with them, we need to interact with them using different terminals. We have to switch between the terminals. So by using terminal UIs, we can create a dashboard where we can interact with all the components using just one button or one click. Yeah. So I will start my demo. Yeah, so so here is the simple code. I will not go deep dive into a code. I will just show the possibilities of the terminal UIs, how you can use that for any application. Okay, so these are the helper functions. So where here we are going to use the TView library. So where basically first define the components. Components are basically we divide the terminal into various sections. So here I am dividing the terminal into a section of log view. You can see here log view, logo view, then logs view, then connection status. Then we have a footer, where in footer we will define how to we will define the information or instructions like how to use this terminal. Okay, we have a search bar here, and inside this we will define this grid. Grid is basically we define the sizes of those sections of the terminal. Okay, so we will create the grid. Yeah, you can. I will not go deep into code. I will share my GitHub repo link, so you can go and check out this. We all are gophers, so yeah, this is a very simple code. Yeah. So here I am using the keyboard inputs to differentiate the log types. Basically, I am using the A for the for to see the all logs, I for the info, W for the warning, E for the error. Okay. So I will now just show you the possibilities in the terminal UIs which you can do. I will not go into a code now. Okay. So here I have a simple client and simple server here. Yeah, so I will send some logs from the client to the server. So you will see the info, warning and error logs are here. Okay. So if I click on I button, we will only see the info logs. If I click on W button, we will see only the warning logs. If I click on the E button, we will see the only error logs. And I can interact with this search bar. First I will go to the all logs. See, the search bar is also working. Okay. So this is the second possibilities where we can have the buttons to see the logs. So let me send some logs, warning, error, and I can click on the buttons to navigate to see all the logs. Okay, so let me show you another possibilities. Yeah, here you can have a drop down menu for the same thing. You can select the drop down menu to view the logs. Yep. Should I finish? There is one more thing. I have created one simple dashboard. Just give me two minutes just. Yeah. So this is the dashboard I have created for the HLF network, where I can see all the components log into one terminal, where I can switch up the network, switch down the network. I can deploy the chain code, and I can see the network info also here. Yeah. Also we have a search bar, and also I can see the peer logs. Peer logs are basically Docker containers. I can interact with Docker container also.
As you see, the title is very big, but the concept is very easy. Here we are predicting high Kafka message payloads and how we are handling those Kafka message payloads for the Kubernetes pods. Okay. And have you ever wondered how we need to efficiently scale our Kubernetes pods to consume and process those messages in an efficient way when an unpredictable message payload happens? As Kubernetes is not account for external payloads or any other workloads, how do we handle those situations? Like, let's say there is a trade market situation where a market outage has happened, and people might start selling or buying their trades, and this might increase a sudden outage of payloads on Kafka because the trading system has been deployed over Kafka. Okay. Now, with the data which we have, or the data which we provide with the autoscaler, we can easily enhance our system on services and also consume those messages and process with system proof. Okay. Now, this Kubernetes, and you can also say that Kubernetes also have its own autoscaler. Then why do we have a separate autoscaler using Go? Kubernetes autoscaler also have its own limitations. Basically, this Kubernetes autoscaler limits on CPU and memory utilizations. And also it doesn't know whether a certain Kafka topic has more messages or certain Kafka topic has very less messages. For that situations, here comes a picture, an autoscaler with Go that is being deployed in a cluster, which is being connected to Kafka and the kube server. This autoscaler continuously checks the metrics of Kafka and calculates over the metrics and enhances the pods which are required for those specific messages. And you're going to say that why we need to use Go for this autoscaler. Why can't we other programming languages? As you can know that Go has a lightweight concurrency, which can efficiently use and consume those messages and have an efficient system things. Also, we have a efficient memory management, which makes our system foolproof. And also, there might be high throughput from Kafka's consumers. This Go, which has a Go routines, which can produce and run concurrently all those messages. And let me show a small demo. Yeah. The left side, there is a cluster being running, and there is a consumer being running, and the Kafka is also connected to it. Now, let's say I'm applying one producer which produces randomly. The autoscaler logic which has been deployed over this cluster is written in such a way that for every 15 seconds, it calculates the number of messages which are being produced in the Kafka, and it decides whether to scale up or scale down the pods. As you can see, the producer came up and it starts producing over the messages. See, it automatically scales up the consumer pod based on the messages, and it automatically scales down as well. That is how it has to be. Thank you.
Hi. So I'll be talking on writing your own generator in Go. So who am I? I am Agni Bhattacharya, and I love programming, traveling, clicking photos. Currently, I'm working at Funnel Story as a software engineer. I'm writing external API clients and integrations, integrating internal APIs in Go, and also recently creating custom AI agents to do cool stuff. In my past experience, I have worked on Python, Flask, Django, and I also managed Kubernetes clusters, upgrades, deployments, and debugging. I also used to work on Terraform and creating help charts. I'm also recently a contributor at Grafana. So what is code generation? Code generation is the process of programmatically generating source code that would otherwise be written manually. So the benefits of generating code is you have minimal bugs because no humans are involved. If you don't write code, you won't have bugs. Reduced boilerplate code saves developer time. And let's talk about Go Generate. So Go Generate has 3 parts: generators, Go directives or magic comments, and Go Generate command. So generators are basically the scripts or commands that are invoked by Go. Go directives, like shown in the example, these are special comments that are recognized by Go. And Go Generate command basically invokes these commands that are specified in the magic comments. For example, this is the most simple Go Generate thing. It's just a echo hello world. If you run the Go Generate command, it will just simply print hello world. One example of this in their Go doc is the stringer interface, stringer generator. I won't go into too much detail as I have a demo. Let's go to the demo. So in the demo, I will be creating a JSON schema from the struct. Okay, I hope you can see it. Okay, so in this struct, we have a JSON IDs, JSON tags here, and this is the schema defined. So anyone who doesn't know about JSON schema, it is basically used for validating and giving a structure to your JSON. This is a sample output that it looks like. Let's go to the generation code. This is how we invoke it using the go run generator.go file. Let's go through the generator file once. Okay, so we have defined a schema field here,
This represents a single field in the JSON schema, and the schema type represents the complete schema structure. This is a template that would be generated. I will go through it later. Let's go through the main file. So what we are using is a parser package, which is the Go native package. It parses the Go file and it creates an abstract syntax tree from it, and we can iterate through the tree using the AST package. This AST.inspect, this code basically runs DFS on starting from the first node, and we basically check what is the type of the current node. We check, is it a type spec? So this is the type, right? Yeah, sorry. Okay, so if it is not a type, then we return true. When we return true, it moves on to the next node. Assuming it's the correct type, we go and check the name of the type. Remember, we passed a type user here. It checks whether the type is a user type. If it is not a user type, we go to the next node. Assuming it's the correct type, we again go further, and then we ensure that it's a struct type. If it's a struct type, we parse the struct. Let's go through this code. Okay, so we are basically defining empty schema, and now we are iterating through the fields in that struct. Okay. If the tag is nil, we don't do anything. We need to parse the tag fields, which is basically we are parsing this. If the JSON tag is nil, we don't do anything. We get the type by parsing the type of the string. And now we check if the tag has a schema. If the tag has a schema, we check the minimum length, and we extract that minimum length from here, which is this. Similar for the format also, not going through that. Okay, let me run the code and show you what it does. If I run go generate, it should generate the JSON schema in this folder here. It generated it. It looks like this. Yeah, that's it. Thank you.